Your Ford EcoBoost Turbo is already dying. And you're the one doing it. Right now, as you watch this video, your turbocharged Ford is taking damage. Not from a blown gasket, not from a freak mechanical failure. From you, from the things you do every single morning, every drive, every time you hook up a trailer. Habits so automatic, you never think twice about them. And they are quietly grinding your turbocharger into dust. I have spent more than 15 years pulling EcoBoost engines apart on my lift. The 1.5, the 2.3, the 2.7, the 3.5. I know every failure point on every one of them. And what I can tell you with absolute confidence after thousands of teardowns is this. The damage I find inside these turbos is almost never random. It follows a pattern. It tells a story. And that story almost always leads back to the owner. Carbon so thick, it turns the center cartridge into a solid black plug. Bearing journals wiped clean from a single cold start thrash. Compressor wheels that look like they've been through a belt sander. I'm not exaggerating when I say I have seen engines with fewer than 90,000 miles that looked like they had 300,000 worth of turbo abuse inside them. Here's the number that should get your attention. Turbocharger replacement on a Ford EcoBoost runs anywhere from $1,500 to $4,000 depending on which engine you have and where you take it. That is just the turbo. If the bearing lets go catastrophically and throws debris into the intake manifold, the intercooler, or down into the engine itself, you are no longer looking at a turbo job. You are looking at a full engine rebuild. I have handed customers invoices north of $8,000 for failures that started with habits that cost absolutely nothing to fix. Today, I'm walking you through the 7 habits that destroy Ford EcoBoost turbos faster than anything else I have encountered in 15 years of doing this work. Some of these are going to feel completely wrong to you because they sound like totally normal behavior. That is exactly what makes them so dangerous. Let's get into it. And before we do, if you own a turbocharged Ford, or you know someone who does, hit that subscribe button right now. Every week I put out content that can save you thousands of dollars in repairs and keep your truck running strong for the long haul. Subscribe, and you will not miss a single one. Habit number 7, killing the engine. Immediately after you've been running it hard. This is the slow, silent killer. It doesn't announce itself. There's no smoke, no warning light, no noise. Your truck just starts running a little rough one day, and by the time you bring it in, the turbo is cooked, literally. Here's what's happening inside your engine that you cannot see. When you drive your EcoBoost hard, or we're talking highway on-ramp pulls, towing up a grade, running sustained high RPM for any extended period, your turbocharger is spinning at somewhere between 100,000 and 200,000 revolutions per minute. Let that number sit with you for a second. 200,000 RPM. The center shaft, bearing that keeps the whole thing alive, is being fed a constant pressurized supply of engine oil, and that oil is the only thing separating a perfectly functioning turbo from a catastrophic metal-on-metal failure. The moment you shut the engine off, the oil pump stops, instantly. Oil pressure drops to 0 in a fraction of a second. But the turbocharger? It does not stop. It keeps spinning on pure rotational momentum, for seconds, sometimes longer if you've really been into it. And during those seconds, that bearing is rotating at tens of thousands of RPM with 0 lubrication. The heat from the exhaust housing, which was glowing during your last hard pull, now has nowhere to go. It bakes the last film of oil that was sitting in the center cartridge. That oil doesn't just get hot, it carbonizes. It turns into a hard, black, varnish-like deposit called coking. And every single time you do this, that deposit gets thicker. It starts to restrict the oil passages, flow decreases, the bearing starts running partially starved. And eventually it fails, usually in the most inconvenient, expensive way possible. The fix costs you nothing except 2 to 3 minutes of your time. After any kind of hard driving, pull into your driveway or parking spot and let the engine sit at idle. Don't touch the AC, don't rev it, just let it idle. 2 to 3 minutes is enough for the turbo shaft to spin down while the oil pump is still running, still circulating fresh oil through the center housing, still carrying away that heat and preventing the coking cycle from starting. You don't need an aftermarket turbo timer, though they absolutely work if you want a set it and forget it solution. You just need to build a habit. Every hard drive ends with a cool down idle, full stop. Do this consistently and you will add years of life to that turbocharger. Habit number 6, hammering a cold engine the second. You start it. This is the one that gets people on busy mornings. You start the truck, it catches immediately, sounds healthy, idles smooth. You've got somewhere to be. You back out of the driveway and you get on it. The engine runs fine, no knock, no rattle, no smoke. So what's the problem? The problem is physics, and it does not care how late you are. When your Ford sits overnight, especially in temperatures below 40 degrees Fahrenheit, the engine oil drains down from all the upper engine components by gravity. It collects in the oil pan at the bottom. The turbocharger, which sits up high on the engine, is now sitting with almost completely dry oil passages in its center cartridge. At startup, the oil pump has to prime the entire system from scratch. It has to pull oil from the pan, push it through the filter, through the main oil galleries, up to the head, and out through the dedicated supply line to the turbocharger bearing. Depending on oil temperature, oil viscosity, and how long the truck has been sitting, that process takes anywhere from 3 to 8 seconds. During those seconds, the turbo bearing is running dry. In a normal cold start where you drive gently, this isn't catastrophic. The turbo isn't spinning fast enough under light load to generate enough heat to cause immediate damage. But if you're flooring it before the oil has made it to that bearing, if the turbo is spooling hard while it's still oil-starved, you are creating the exact conditions for accelerated bearing wear, or, in the worst case, a spun bearing on a relatively low-mileage engine. EcoBoost engines build exhaust heat extremely fast under load, even when cold. Pair that with a dry turbo bearing, and you're not just wearing it, you're scorching it. Ford actually addresses this in the owner's manual under the warm-up section. They recommend avoiding high engine loads during the initial warm-up period. Almost nobody reads that section. Almost nobody knows it exists. The fix is easy. Give yourself 60 seconds of gentle, easy driving after a cold start. Not sitting still in the driveway warming up. That's outdated advice from the carbureted era, and it wastes fuel. Just drive easy, keep the throttle light, don't merge aggressively or load the engine for the first minute. That's enough time for the oil to circulate fully and get proper pressure to the turbo bearing before you start spinning it hard. On mornings below freezing, extend that easy period to 90 seconds. And do yourself a favor. If you're not already running a full synthetic motor oil like Motorcraft 5W30, switch. Full synthetic flows significantly faster at cold temperatures than conventional or synthetic blend oil, which means it reaches the turbo bearing sooner after startup. On an EcoBoost engine, that difference in those first few seconds matters more than most people realize. Habit number 5. Running the wrong oil or stretching your oil changes. I am going to be direct about this one because I see it constantly, and the owners who do it usually think they are being smart with their money. They are not. Ford's EcoBoost family of engines is built to extremely tight tolerances. The turbocharger bearing clearances are measured in thousandths of an inch. The engineering team that designed these engines did not choose the oil specification arbitrarily. They chose it because the viscosity, the additive package, and the thermal stability of that specific oil type are calibrated to match what these engines actually experience during operation. Ford specifies SAE 5W30 full synthetic motor oil, meeting the Motorcraft SP or WSS M2C946 B1 specification for the majority of EcoBoost applications. Some owners substitute whatever is cheapest at the auto parts store. Some use whatever is on sale, regardless of whether it meets the Ford spec. Others run a 5W20 because they have it left over from their old naturally aspirated engine. All of those decisions introduce risk. An oil that does not carry the correct additive package for a turbocharged application cannot handle the heat cycling these engines produce. It breaks down between changes. An oil breakdown in a turbo bearing does not just mean reduced lubrication. It means deposits, varnish, and the beginning of the coking cycle we already talked about. The second piece of this is oil change intervals. Ford's intelligent oil life monitor is sophisticated, and under perfect conditions, highway miles, moderate temperatures, light loads, it can legitimately stretch intervals out toward 10,000 miles. Under those conditions, it's probably fine. But if you're towing regularly, if you drive in stop and go traffic, if you're in a hot climate, or if you run your EcoBoost hard, and let's be honest, most of you reading this do at least one of those things, that monitor is not accurately reflecting what is happening to the oil that is circulating through your turbocharger bearing. The turbo center cartridge operates at temperatures that can exceed 1,000 degrees Fahrenheit on the exhaust side during heavy use. Oil passing through that environment degrades at a rate that the rest of the engine never demands of it. Your oil might be perfectly adequate for the bottom end at 9,000 miles, but completely spent from a turbo perspective. My personal recommendation for anyone running their EcoBoost under any kind of stress is a 5,000 to 6,000 mile change interval, regardless of what the dash monitor says. An extra oil change per year costs roughly $80 to $120. A turbocharger costs $1,500 minimum. I have never once had a customer argue with that math once I explain it to them. Check your oil level at the dipstick regularly. Dark oil is somewhat normal on a turbocharged engine, don't panic about color alone. But oil that smells burnt, feels thin between your fingers, or sits below the minimum mark is telling you something your turbo cannot afford to have you ignore. Habit number 4. Running hard with a dirty air filter. The turbocharger on your EcoBoost has one primary job: compress air and force it into the engine at higher than atmospheric pressure. To do that, it spins a precisely machined compressor wheel inside a precision machined aluminum housing. The clearance between the tips of those compressor blades and the inner wall of the housing is a few thousandths of an inch. Now here's what happens when your air filter is dirty. A clogged or degraded air filter creates restriction on the inlet side of the turbocharger. The compressor wheel is trying to pull air through a plugged filter, creating a localized low pressure zone. That pressure differential physically pulls the turbo shaft toward the compressor side, loading the bearing in a direction it was not designed to handle continuously. Over time, that loading causes intermittent contact between the compressor wheel blades and the housing wall. If you pull a turbo off a truck that's been running with a neglected air filter, you will see it clearly. A groove machined into the inner surface of the compressor housing, and the blade tips worn flat. The compressor wheel is no longer moving the air volume it was designed to move. The turbo compensates by spinning faster. It runs hotter. The bearing takes more load, and eventually it's done. The second problem with the dirty filter is particle ingestion. As the filter media becomes overloaded and begins to break down, it allows fine particulates, dust, carbon, road grit, to pass through and get drawn directly into the turbo compressor inlet. Those particles hit the compressor wheel blades at high velocity and act exactly like fine grit sandpaper. This erosion damage is progressive and irreversible. Once the blade profiles are degraded, the turbo is permanently compromised. Ford specifies air filter replacement every 15,000 to 30,000 miles, depending on operating conditions. If you drive on unpaved roads, gravel surfaces, construction areas, or in any environment with elevated airborne particulates, cut that interval in half and start doing visual inspections more frequently. Pull your air filter and hold it up to a light source. If you cannot see light passing cleanly through the filter media, replace it. The filter is done whether or not it has reached any mileage milestone. OEM quality air filters run $20 to $40. The turbocharger they protect costs up to 100 times that. This is not a difficult cost-benefit analysis. Habit number 3, ignoring boost system, leaks, and hose condition. Between your turbocharger and your engine sits a pressurized network of silicone hoses, rubber couplers, metal pipes, clamps, and an intercooler. Every joint in that system is a potential failure point. And when any one of them develops a leak, even a small one, the consequences for your turbocharger can be severe. Here's the mechanism. Your engine's boost control system monitors pressure throughout the intake tract. When a hose or coupler starts leaking, pressure drops below the target level. The ECU responds by commanding the turbocharger to build more boost. The turbo responds by spinning faster. If the leak is significant, or if it's in a location where the pressure sensor can't accurately detect it, the system can drive the turbocharger well beyond its intended operating range. Trying to compensate for pressure, it can never fully recover. I have pulled turbos off EcoBoost F150s that were spun to failure, chasing a boost target they could never hit, all because of a cracked coupler at the intercooler outlet that cost $15 to replace. The turbo cost over $2,000. Boost leaks also allow unmetered air into the intake, air that the mass airflow sensor never measured. This throws off the fuel trim and causes the engine to run lean under boost. Running lean under load means combustion temperatures spike. That thermal spike translates directly into heat load on the turbocharger's turbine side components, which are already operating in the hottest part of the engine. The most vulnerable points on Ford EcoBoost engines are the intercooler inlet and outlet couplers, which are held on with simple spring or screw clamps that loosen from vibration over time. On the 3.5-liter EcoBoost in particular, the lower intercooler hose has a well-documented tendency to crack at the bend. It's a known issue. It's also a cheap fix if you catch it before it takes the turbo with it. Symptoms to watch for: a fluttering or whooshing sound under hard acceleration, a reduction in power that seems especially pronounced at highway speeds, or a check engine light with boost-related diagnostic codes. Any of those signs should send you straight to a visual inspection of every boost hose and clamp in the system. Pop the hood, put your hands on those couplers, squeeze them, look for cracking at the ends or along the bends, check the clamps for movement. Catching a cracked boost hose before it causes turbo damage is one of the cheapest preventive repairs you will ever do on a turbocharged vehicle. Habit number 2, towing heavy without proper preparation or monitoring. This habit produces more catastrophic, complete turbocharger failures than almost anything else I see come through my shop. And it consistently involves owners who are doing exactly what they believe their truck was built to do, just without the preparation and attention the job actually requires. Ford's EcoBoost engines are genuinely impressive towers for their displacement. The 3.5-liter in a properly configured F-150 can move over 13,000 pounds. That capability is real. But it exists within a defined envelope of conditions: operating temperature, coolant level, oil condition, ambient temperature, grade percentage, and duration of load. Step outside that envelope, and the turbocharger is the first component to pay the price. Under sustained heavy towing, particularly on grades or in hot ambient temperatures, exhaust gas temperatures on EcoBoost engines reach levels that push the turbocharger's thermal limits. The turbine wheel on the hot side of the turbo is operating inside exhaust gases that can exceed 1,600 degrees Fahrenheit during sustained high-load pulls. At those temperatures, even partially restricted oil passages, the kind that build up gradually from coking, can cause the oil film in the center bearing to flash vaporize. When that happens, the bearing runs completely dry under full load at maximum temperature. The result is usually a spun bearing, or in severe cases, a cracked turbine housing. Either way, you're looking at a full turbo replacement. The secondary issue with heavy towing is coolant temperature. Under sustained load, if your cooling system has any weakness, low coolant level, a marginal thermostat, even a partially blocked radiator, the coolant temperature will begin to climb. I have watched owners push through a rising temperature gauge because they were almost to the top of a grade. Some of them made it. Some of them arrived at the summit with a seized turbo and an engine that had already started cooking internally. If your coolant temperature gauge is climbing beyond its normal operating range while towing, pull over. Don't push through it. Don't negotiate with physics. Pull over. Let the engine idle, not shut off. Idle for 5 minutes. Give the cooling system a chance to recover before you continue. Before any significant tow, check your coolant level when the engine is cold. Check your oil level and condition. If your oil is dark and overdue, change it before the tow, not after. And once you're underway, keep one eye on your gauges. They are there to give you information in real time. Use them. When you arrive and unhook the trailer, do not shut the engine off immediately. Run through the same cool down idle we discussed in Habit 7. After a hard tow, your turbocharger has been operating at the extreme end of its thermal envelope for potentially hours. Shutting it off cold is one of the worst things you can do. Give it 3 to 5 minutes of idle time to come down properly. Habit number 1, ignoring the warning signs. Your turbo is already giving you. This is the habit that turns a $300 repair into a $3,500 repair, sometimes into a $7,000 repair. And it happens every single week in shops like mine because owners either don't recognize what their engine is trying to tell them, or they hear it and decide to hope it goes away on its own. It never goes away on its own. Turbocharged engines communicate. They give you signals well in advance of catastrophic failure. Your job is to know what those signals mean and act on them before they escalate. The first signal is blue or white smoke at startup that burns off after the engine warms up. This means oil is seeping past the turbocharger's internal seals, either into the intake side, the exhaust side, or both. At this stage, the bearing is still functional. The turbo may still be rebuildable. In some cases, the fix is as simple as clearing a restricted oil return line that's causing oil to back up and force past the seals under pressure. Ignore it for another 10,000 miles, and those seals fail completely. The turbo begins ingesting significant volumes of oil. You now have an oil consumption problem, a fouled catalytic converter, and a turbocharger that needs full replacement. Catch it early and you might walk out the door under $400. Miss the window and the bill grows fast. The second signal is a high-pitched whine or whistling sound that tracks with engine RPM, meaning it changes pitch as the engine speeds up or slows down. This is bearing noise. It means the turboshaft is developing axial or radial play. The compressor or turbine wheel is starting to contact the housing under certain conditions. At this stage, a quality turbo rebuild kit and a few hours of shop time might be all that's needed. But if you continue driving on it, if the whine graduates into a grinding or clattering sound, the housing itself has been damaged. A rebuild will not restore it. You need a new unit. The third signal is consistent, repeatable power loss under boost. Not the occasional flat spot, but a noticeable, predictable reduction in performance every time you ask for it. This often points to either a sticking variable geometry vane system on turbos equipped with that technology, or a failing wastegate, actuator that's bleeding boost off before it reaches the target level. Both of those conditions force the turbocharger to compensate by working harder than it's designed to, which accelerates bearing wear. A vane cleaning service or actuator replacement runs a few $100s. A turbocharger that destroyed itself while trying to overcome a stuck wastegate costs several times that. EcoBoost engines have gotten a reputation in some corners of the internet for being turbo killers. Based on what I see in my shop, that reputation is only partially earned. The turbos Ford spec'd for these engines are capable, well-engineered components. They are built to last the life of the vehicle when they're properly maintained and operated within their design parameters. The failures I see, consistently, repeatedly, come down to one or more of the 7 habits on this list. Owners who respect the cool-down process, run the right oil on schedule, keep their air filter fresh, monitor their boost system, tow responsibly, and respond to early warning signs are putting EcoBoost engines past 200,000 miles without touching the turbocharger. The owners blowing turbos at 80,000 miles are the ones doing several of these things simultaneously and wondering why their supposedly reliable truck keeps letting them down. Go back through this list honestly. Not how you plan to drive, and how you actually drive. If you're doing any of these 7 things, today is the day to stop. Your turbocharger is a precision component operating at speeds and temperatures that most people have never thought about. Treat it like the precision component it is, and it will be there every single morning for the life of your truck. Before I let you go, if this video gave you something useful, hit that subscribe button right now. I put out in-depth content like this every week, specifically for Ford owners who want to stay ahead of expensive repairs instead of reacting to them after the damage is done. Subscribe so you don't miss the next one. Drop a comment below and tell me honestly, which of these 7 habits have you been guilty of? I read every one of them. And if you know another Ford owner who is running their EcoBoost hard without knowing any of this, send them this video. You might just save them a very painful check to write. I'll see you in the next one.